some questions that I got in class on these problems. First one was number 5 down here. The conversion problems. Well, the key to these is you start here with a given rate of 30 rotations per minute. 30 rotations per minute. And we have to turn it into, at the end, miles per hour. So we're going to put the conversion factors in there to change minutes to hours, rotations to mile. And the key is this one right here, which is the circumference formula, really, which is 2 pi r. One rotation is 2 pi r. So if you put this conversion factor in here, everything will cancel out nicely and you'll be able to get down to what you need. Another question I had was on the problem 7 here, the length of the arc. Well, this is a formula, circumference equals pi times diameter. Circumference is also 2 pi r. When you're doing with the radius, use this one, but I use the diameter here. And I just put in pi times the diameter, and I put in right here that it's 80 degrees out of 360. That's the parts. Some other questions I got. Number 13 here. The key on these problems is always, of course, to draw a triangle. And you're given that tangent is equal to 5, which means the opposite of adjacent, 5 over 1, which is root 26. And then once you have the parts here, you can find cosecant, which is reciprocal of sine, and you have it there. Number 17, the period of a cosine graph. Well, the period of regular cosine is 2 pi. However, there's a b value there. So the b value means you take this and divide it by this b value. And what I have written here is 2 pi divided by b. B is 4, so the period is pi over 2. Amplitude here, it's going up 5 and down 5, so the amplitude's 5, and the midline's 4. Again, the midline is 0 because that's the middle. And what is a period? Well, a period is from one point where it hits the midline to another point where it hits the midline. It goes up, down, up, and then down, and then back up. That's one wave of pi. That's one period. Some other questions I had here. Number 28, using these formulas. Well, you have everything you need in this picture. You have sine value, cosine value, opposite, adjacent, tangent, everything you need. All of your values, whatever you need, you can find right in here. And to find these formulas, we just have these one, this one, and this one, and this one, and those are the double angle formulas. You have those on your sheet. Sine of 2 pi is 2 sine of theta cosine of theta. And you can just plug them in there, and there's the 2, there's a sine value, there's a cosine. And for cosine, you have multiple options, and for tangent, there's options there. So just take the values, plug them in the formulas. Number 30, solving this equation here. Always change this one to 1 minus sine squared, and then you just have to go through the work of solving the equation. Couple other questions we had here. The area of a triangle. When you have a side angle on the side, the formula is 1/2 the two sides times the sine of the included angle there. So you can just get to it that way and save yourself a lot of work. One other one I wanted to talk about, number 41 here. On these kind of problems, what you want to do is go ahead and draw this triangle here. But make sure you pay attention to what quadrant it is. So it's a quadrant 2 triangle. So the sine is 2 over 3, opposite over hypotenuse. You can figure out that value, and then you can go ahead and do the tangent. A couple other questions I had. Now these numbers may not match what you have on your new worksheet. These were old numbers from last time, so the problems will match here. Number 44, the period of a sine function always starts off at 2 pi, and the period of a tangent function starts off at pi. What other ones did we have here? This is a cosine rule formula. You can just plug everything in, subtract over, divide by that. Solving equations. This one, number 60, is a problem that requires the sum and difference formulas that are on your reference sheet right there. All of these values, of course, are from the unit circle. Number 65, the angle of elevation and the angle of depression are the same thing because they're alternate interior angles. So this one's looking up, that one's looking down. Those are the same. All right, if you have more questions, please let me know in class. I'll be happy to go over it and help out.